This is Algebra 1, Lesson 7-5, simplifying square roots with variables this time. Today's date is Thursday, January 28th, 2021. Our objective today is to remove perfect square integers and perfect square variables from square roots. All right, so we were already doing this yesterday, perfect square integers. The only change now is there's going to be some perfect square variables also included in here. Again, this is the second of our three last lessons in Unit 7, where the next lesson tomorrow is going to be the penultimate level. All right, so I'm really using two key facts. And the first really big one is if I have anything that's squared inside of the square root symbol here, then they cancel each other out. The square and square root are inverse operations, and you're left with whatever the anything. I should write slower. Anything that you started with. So, for example, if I have something like 4 squared square rooted, that means I get 4. The square and square root, I call that, they cancel each other out. They are inverse operations of each other. So that's kind of the big fact. And the other fact is, how do I get something with a square? And there's tricky ways of doing that, and I'll show you with some examples down here. Those are the two big things from today's lesson. So let's go back in time to yesterday when we were just talking about square root of 360, the square root of 128. You didn't do these problems, maybe you did them in the homework, but not in the lesson. So I'm going to do this in a slightly different way to show you some cool logic that can happen. So I did the entire factor tree of 360. So if I did 360, I'd say, that's 2 times 180. And I say 180, that's 2 times 90. I kept going on and on until I got the ends of the tree branches, chunk, chunk, and all the way down here. All of the ends of the tree branches are right there. Those are all of the factors of 360, the prime factorization. And then I kind of just grouped together like terms. So I said, how many of these 2's do I have? Well, I have 3 of them. Why did you do that, Mr. Snell? Why don't I just put 2 to the power of 3 there? Well, because I want to do the biggest even number and then whatever is remaining. So the biggest even number here is 2. So I put a 2 here, and then there's 1 remaining, so I just left it here. Again, there are 2 3's. Perfect. There's no remaining 3 because there's just 2 of them. And then there's 1 5, so I just left the 1 5. You might be asking, well, why are you leaving the biggest even number? And the answer is, look, there's a square there. That's the whole point. We want to get something with a square here so we can get rid of it. So whenever you have the square root of a bunch of things being multiplied, you can break it apart. See, I have this, and I broke it apart, shunk, 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 into those 4 pieces. You're allowed to do that. It's a rule of exponents, technically, but it's just a property of square roots or roots in general that you need to know. Okay, and check this out. Now that I've broken it up, what is this? 2 squared and square rooted? Well, the square and square root, shoink, shoink, cancel each other out, and I'm left with just 2. Well, the square root of 2, I can't do anything with. That's still square root of 2. But hey, look again. I have a square and square root, shoink, shoink. Those cancel each other out, and there's my 3. And square root of 5, okay, and can't do anything with that. So I think you understand to get from here to here now. And then finally, I can just kind of rearrange things. Whenever things are being multiplied, if I say 2 times 3, that's the same thing as 3 times 2. I'm allowed to switch the order of things. So I just switch the order. I just put all the non-square roots, the non-radicals on the left, all the square roots on the right. And whenever you have a square root times a square root, you're allowed to just write it under one giant root. One radical symbol, if I'm being technical about it. And then you just multiply. 2 times 3, 6. 2 times 5, 10. And that is another third way of thinking about how to do your simplifying of square roots. Why am I doing it this way? Because this way makes a lot more sense when I'm talking about variables. It gives you the logic behind what I'm going to do when I get down here with variables. I want to show you one more example. So let's talk about 128. This is just 2 to the power of 7. If I come into my Desmos, or not my Desmos, Spotlight search, 2 to the power of 7, this little caret symbol is shift 6. It means the power of 7. You can see that is 128. So you can see, you can kind of just jump from here to here. That makes sense. It's really 7 of those 2's. Again, if you just did a factor tree, you'd get the ends of the branches right there of 7 of those 2's. But the problem here is I want this to be an even number. And you'll see why in a sec. So I'm going to make this 2 to the power of 6 and then a 2. This works because there's 6 of those 2's and then 1 of those 2's for a total of 7 of those 2's. You can use properties of exponents to explain that away. 6 plus 1 is 7. And then from here, I want to rewrite 2 to the power of 6 with a square. Again, I want some sort of 2 in the exponent. That way I can cancel something out. So I'm going to rewrite this as 2 to the power of 3 to the power of 2. And again, using properties of exponents, this works because when I have a power to the power, this means I multiply. 2 times 3 is 6. So it's kind of like I'm going backwards with my properties of exponents, but that's still allowed. You're allowed to go forwards or backwards. And now that I have this 2, I can finally get rid of it. So first I'm going to break it apart, just kind of cut it in half like I do right here. And then I have a square root and a square. Those two cancel out, and I'm left with 2 to the power of 3. I still have to rewrite that square root of 2 as well, and I get 2 to the power of 3, which is 8. You can say 2 times 2 is 4, times 2 again is 8, and leave the square root of 2. So I can get 8 root 2. All right, so I think you kind of understand you want to get an even number so that you can get a 2 kind of boiled out of it. So let's come down here and play with some variables. I'm now adding variables into the mix. I want to take the square root of 72x to the power of 9. So this is really two problems. I'm dealing with the square root of 72, and the second problem, I'm dealing with x to the power of 9. You already know how to do the square root of 72. I'm not going to reteach that. That was lesson 7-4. Now I'm showing you the logic behind how to do the square root of x to the power of 9 and simplify that. So I'm doing the smart method here. I see that 72 is really 36 times 2, and 36 is that perfect square, which will make my life much easier. And the way that I separated this x to the power of 9 is I want an even number. So I do power of 8, and then I have 1 left over. If this was already an even number, then I don't have to do this step of breaking it apart. It's already there as an even number. All right, so now that I've made an even number, what can I do? I can break it into 4 pieces. Chop, chop, chop. And you can see that's exactly what I'm doing in this step right here. I'm just separating it into multiplication. Okay, now I get to actually simplify. The square root of 36 is 6. The square root of 2 is still the square root of 2. Okay, this is kind of the cool step. What do I do to get from here to here? Well, I had an even number, which is the whole point. I want an even number so I can write this as a power of 2. You can see, oh yeah, 4 times 2, Mr. Sindel. Yeah, that's 8. I agree. Thumbs up. Pat yourself on the back. You understand what's going on? Well, the 2 and the square root cancel each other out, and I'm left with just this x to the power of 4 over here. Then I rewrite that square root of x, and I write out my final answer. I'm going to group all of my square roots. I have a 2 and an x, so 2 times x is just 2x. That's under the radical symbol. And then I group all the non-radical. I have a 6 and x to the power of 4, so I'll write 6x to the power of 4. And this is what I'm expecting you to be able to give me when I give you a problem like the square root of 72x to the power of 9. So I can generalize that procedure that I just did up here. First, you're going to do everything that we did in lesson 7-4. You're going to use a factor tree. You're going to simplify the coefficient. So this is essentially do lesson 7-4. You know how to do, and that's just talking about the coefficient. But how do you do the variables? This is kind of the new stuff. All right, this is your new material. So you're going to separate the variable so that it has an even power, like I did up here. This was an odd power, and I made it even. Sometimes you can skip. So I'll say sometimes skip. Sometimes you can skip this. When can you skip it? If you already have an even power, then you don't need to do anything. It's already an even power. You can immediately skip then to step 3, which is you need to divide the variable exponent by 2. Look, I had 8. 8 divided by 2 is 4. And then you can just get rid of the square root. I mean, that's skipping a step. I'm essentially skipping from here all the way over here. You can divide by 2 and get rid of the square root. Divide by 2, get rid of the square root. That's how I got from here to here. That is the shortcut that I'm showing you. If you want to do this long way, that's even better. That shows that you really know what's going on, but this is your shortcut. Maybe I can new procedure shortcut. I'm always wary of teaching students shortcuts because they don't understand where they come from, but I explained where it came from up here. If you don't understand this, then keep doing it until you understand it, and then you can start using the shortcut. Let's do an example. So I have a feeling that you probably are going to get lost because I'm just showing you this for the first time. I still want you to attempt it. You might not get very far. Pause the video now. All right, you've paused the video and you're now unpausing the video. Again, the square root of 56, I'm thinking, okay, 2 goes into that, 4 probably goes into it. I can check with the calculator. These are calculator-enabled problems. 56, is that divisible by 4? It is. 4 times 14. So I'm going to go ahead and rewrite that now as the square root of 4 times the square root of 14 times, okay, I want to get this y, and I can skip a step. I'm going to do it the longer way for this example 1. Maybe I'll skip a step in example 2. I want this y to the power of 10. I want it as an even power, so I'll say square root of y to the power of 10 times the square root of y. All right, and then I can simplify a little bit more. On my next step, I can say, okay, the square root of 4, I know that's 2, so I have 2 root 14. And then what do I have over here? This, again, using the shortcut, I just say y to the power of 5. But the full logic is this is really times y to the power of 5 to the power of 2, and then that whole quantity square rooted. And then I have to rewrite that square root of y. And then from here, you know the next step. The square root and square cancel each other out. That was the purpose of writing that 2 in the first place. And I can kind of, I'll do 2 more steps. So I'll say this is 2 root 14, nothing has changed over there, times y to the power of 5, the square and square root are gone, times the square root of y. And then I'm going to combine all my square roots and my non-square roots for my final step. And I'll say I have a 2y to the power of 5 out front, 2y to the power of 5, and then the thing that's underneath this radical symbol is 14y, and I box my answer. All right, let's go to example number 2. I need to simplify the square root of 48a to the power of 6, and you might notice that there's a shortcut in this one where I don't have to do step number 2 in the procedure up here because it's already an even exponent, so it does skip a step. Again, pause the video now, attempt this on your own. All right, so you've now attempted the problem and you're unpausing the video. This is how you do it. You see this square root of 48 and you're thinking, I see 4. 4 goes into 48, and you might be thinking, I bet even a bigger number goes in there, like 16, because you're really experienced at these now. You can check. So 48, yes, it's divisible by 4 because 4 times 12, but I know 12 has another 4 in it. 12 is 4 times 3, so it must be divisible by 16, is it? Yeah, 48 is 16 times 3. So I'm going to say that this is equal to the square root of 16 times the square root of 3, and that's just, again, from lesson 7-4. Now the lesson for 7-5, how do I do this a to the power of 6? I'm going to go ahead and skip a step. My shortcut is divide that by 2 and get rid of the square root. It's already an even number, so I get to do that. If it's even number, divide by 2. This is a to the power of 3, no square root, and I'm almost done. One final step. I could say the square root of 16 is 4. Now I'm going to combine all of my non-square roots. I have an a to the power of 3 term, and I have a square root of 3. Final answer, and box it. And this is utilizing all of the power of doing the quick method with using the shortcut with skipping step 2. This is as fast as problems will go. I know that might be too fast. You might not have understood that. It's a YouTube video. You can replay it. Final example number 3. The square root of 75b to the power of 5. It's an odd power here, so I do have to do that step 2 from up above. Again, let's do the square root of 75 first, and I immediately think 75 cents, that's 3/4 if I had that in my pocket, so it's definitely going to be the square root of 3 times the square root of 25. 25 is the biggest square that can go into 75. And then from there, I have b to the power of 5, and if you're clever, you can do this all in one step, but if you haven't seen this before, I'm going to go nice and slow. This is going to be b to the power of 4, sorry, the square root of b to the power of 4, and all of these, by the way, are being multiplied. If I don't write any symbol, you kind of assume that they're being multiplied, but I'll write this little dot that says multiply by the square root of b. Again, 1 plus 4, this is really a 1 here, an invisible 1. 1 plus 4 is 5, so I can't separate it like that. Next step, the square root of 25, I know what that is. That's going to be, I'll rewrite the square root of 3 times 5 times, okay, so I'm going to use a shortcut now. Whenever I have a square root of an even exponent, this exponent gets divided by 2, and I can just write b to the power of 2 with no radical symbol. And this is going to be times the square root of b still. I don't write b to the power of 1. That's not simplified. This is unsimplified. So now I'm going to group all of my non-radical terms. This is going to be 5b to the second power, and this is going to be the root of, and then combine b and 3, so I'll say 3b, and final answer, box it. That concludes Algebra 1, Lesson 7-5. You have one homework assignment on Khan Academy tonight. Please let me know if you have questions, and I will see you guys tomorrow.